Okay, hi everyone. In this video, I want to try to explain what we mean by a confidence level. We're going to be hearing that a lot in the next videos when we talk about finding confidence intervals. So I want to do by just doing a little hypothetical. Let's say that we know that the average age of all community college students is 22 years old with a standard deviation of 2 years. And going back to what we did way at the beginning of the semester, I'm going to just draw a normal curve where, for our purposes, all our data is normally distributed. And we're talking about the age of community college students, and we're told that the mean equals 22. So how old is somebody who is 2 standard deviations above the mean, where z equals 2? Well, 1 standard deviation above the mean would be 22 plus 2, which is 4. And another standard deviation would be another 2 years would bring us to 26 years old. And on the other side, how old is somebody who is 2 standard deviations below the mean? They would be 18 years old. So if we think back to the empirical rule, remember that 95% of our population lies within 2 standard deviations of the mean, right? 95%. So let's say, hypothetically, I were to walk down the halls of Bunker Hill and I were to randomly pick a person walking down the hall, bring them into our classroom and say, take a guess how old this person is. Well, would you feel very confident just guessing the age? Probably not. You might not bet a lot of money on guessing his or her age correctly. But what if I gave you a range, an interval? I said you could have a range of, say, 8 years. Well, then you might realize, well, I am 95% confident that this person that I've chosen, he, she, is between the ages 18 and 26. Okay? And that's the way we sort of use the term confidence. I'm 95% confident. What does that mean? It means that I know that 95% of the population lies within this range right here, within this interval. Okay? And why do we do all this? Well, it's going to lead to what we will be doing. What I want you to do is I want you to think of this distance above and below the mean as what we call an error. An error. And all the error is, our error is just equal to whatever the standard deviation is that we want, or in other words, this is what we call this 95% confidence. Let me get another color here. Is our critical value. It's our, remember, critical value, and there's a previous video on that. How do you find those critical values? Hang on. Hopefully that's a little better. Critical value of, and if you did this one, you probably, the actual critical value is 1.96 when we use the Z table. So we're approximating, but, and this, sorry, this is negative 1.96 and this is 1.96. But that's that Z score. And we're going to, it would, of 1.96, or for these purposes to simplify it to 2. It means that we're within those 2 standard deviations. So that error comes from whatever the standard deviation is times that critical value, or in other words, how many standard deviations, how far out do you want to be? 95% confidence means we need to go out to this 2 and negative 2, or to the 2 standard deviations out. So, for example, let's say I'm allowed even a bigger range. Let's say I can go all the way out here to 3 standard deviations. Okay, negative 3, well, 26. Now we're talking about a range of 16 to 28. So how confident are you that this random person you choose is between the ages of 16 and 28? Well, now we're even more confident because the interval is even bigger. And we now know that 99.7% of the population is under here. So just to simplify, I am 99 point, well, now I'll leave it as 0.7% confident that This person is between 16 and 28. And then in the previous video, we looked at how to find these critical values, So you can have all different kinds of confidence levels. I am 90% confident. Well, what happens when you're 90% confident? Now that space in here, let me pick another color, that space in here now becomes narrower, right? So we're less confident, 90% is in here, and you can find those critical values. What was the critical value for 90%? And if you need to help with that, you can watch the other video. But that was about 1.5, or z equals 1.645 specifically, or approximately 1.5. So this is roughly the age of 22. 23, 24, 25 years old about here, or 25 years old here. And this direction would be 3 years under, which would be about 19. And so we would be 90% confident that this person is between the ages of 19 and 25. So you can see the higher your confidence, the bigger the interval needs to be. All right, the less confidence you have, the lower percentage of confidence, the narrower your interval will be. And that's the way you really think about what a confidence level is. All right, how does this actually work for our purposes? Okay, what's another thing that might affect the size of the confidence interval? Well, before I was talking about randomly choosing one person. Let's say now we know, using the same information, we know the mean is 22 and the standard deviation is 2 years. What if I now walked out into the hall and I grabbed 10 people, or actually 16. Let's say n equals 16. I grabbed 16 people, and I want you to guess the mean age of all 16 people. So in other words, I ask all 16 people their ages. I add those up and divide by 16, find the average. I found the average. Now, I still know the mean is of the whole community college population is 22 and the standard deviation is 2. But what do you think is going to happen? Are you more confident about an average or each individual person? Think about it, because that's what happens. Remember, with the averages, the standard deviation gets smaller because the outliers get pulled in. So even if you picked 16 people and one person is quite a bit older, say 35, way outside of 3 standard deviations, if you're averaging them with 15 other people, it's going to pull you closer to the mean. How much closer? How does that standard deviation change? Well, we know that from previously. The new standard deviation equals the original one of 2 divided by the square root of the sample size. So now suddenly my new standard deviation is 5. Well, that's going to change things. So now what am I 95% confident about? A much smaller range, right? Let's keep this at 2 and -2 again for simplification. But now my standard deviation is only 0.5. So somebody 2 standard deviations above the mean is only 23 years old. And somebody 2 standard deviations below the mean is only 21 years old. Because remember that error is this distance and this distance. The error is equal to the this critical value, the ZC, times the standard deviation, which we want within 2 standard deviations because we know that we're talking about 95%. So we want to use 2 times the standard deviation of 0.5, which is equal to 1. So now my error is 1. I'm only 1 this way and 1 this way. So I'm now instead of having that big range, I'm 95% confident that the mean sample age, the mean age of my 16 students is between 21 and 23. So that's another thing that's going to affect your confidence level. As n goes up, as your sample size goes up, your interval, your confidence interval is going to go down. Okay. We don't actually use confidence intervals to answer questions like that. We like this. We do it really in the reverse. Let's take quickly a look at one of those. Okay, an actual question for statisticians might be um, to find, usually in statistics, we're trying to draw conclusions about populations as a whole because most studies cannot be done on an entire population. So let's say I have the question, find the true mean age, or in other words, mean of um, all community college students. And let's say I know that the standard deviation is 2 years. We'll get into that a little bit later, but we'll say that. So what do you actually do in these situations? Well, if you want to figure out the age of all community college students, the mean age, the average age, you can't possibly ask every college student. So what do? We take a sample. Now let's say we ask those 16 students. We'll randomly pick 16 students all across the country, ask them their age. And when we do that, we average that out, and let's say it turns out to be 21 years old. Okay? 21 years old for those 16 people. We ask them their age, and we find the mean age. We know that the standard deviation for the population is 2. And so we know that the new standard deviation for this set is just from the previous slide is now going to be 0.5 because 2 divided by the square root of 16 is 0.5. Okay? And let's say, oh, I forgot to put that up here in the question. You always want to ask, find the true mean age of all community colleges students at a 95% confidence. You have to give that level of confidence that you want because we can't find that exact value. We'll never be able to find the exact value. So what do? Well, we know that the, if I draw a little line here, we know that the mean is here at, let's see, the mean is here at 21. The mean of our, the mean of our, sorry, my daughter's quacking at me. The mean of our sample size is 21 years. This is age. Okay, I'm not going to do the whole normal curve, but we're going to create some sort of interval here for where the actual mean is, the true mean. All right, and so what we need to do is come up with, I'm sorry, this should be equal here. Equal. We've got to find this error. Error this direction and error this direction. Okay, and what is that error? The error is equal to the z-score, or the critical value, times the standard deviation, the new standard deviation. So that's going to be we're going to use, we want 95% confidence. And again, to keep it simple, I'm going to just say that's 2. All right, we know that that's the 2 times the new standard deviation of 0.5, which is equal to 1. So we've got an error of 1 year. So we're going to add 1 year this way and 1 year this way. And it's going to bring us to 22 and 20. All right. And so we can be 95% confident that the true mean of the population, the true average age of all community college students, given our little sample stuff over here, is going to lie between 20 and 22. All right. So we are 95% confident that the mean age of all community college students is between, we can't give an exact value, but it's between 20 and 22 years old. All right. So are we certain that it's in there? No, we are 95% confident. Now this is a really simple problem, and we're going to also look at population proportions in confidence intervals in the next video. But here's just a little intro to what do we really mean when we talk about a certain level of confidence.